So here is example 13 from the booklet. I've drawn a scale diagram of the question where we label the points clockwise, A, B, C and D. This force is acting in the direction AB, so we're going to put a pushing force there. I'm going to draw the resultant in now, since we know the resultant is acting at 30 degrees to the horizontal AB. So the resultant is going to go along this line somewhere, and we're going to say it's there. Okay, we can label this angle between the line AB and R 30 degrees. If we wanted to, we could draw the tip to tail or the parallelogram method, so we know that this would be P, and then this other force creates the resultant. Let's call it Q. And this angle we know is 30. Okay, so this, we're drawing it to the centre of mass, which is going to be useful at some point. Okay. So yeah, we've extended R through the centre of mass, or centre of the table rather. What we're also going to do is we're going to imagine, since P and Q meet where R starts on the edge AB, we can sort of reverse engineer that and put the point X in where Q is acting from. I will do that in a moment. So this is extending the line for Q. Q is acting in this direction at this point X, and let's call this angle theta. Okay, so this is possibly the diagram that you drew. So notice in the diagram how if we extend P and Q up to the line AB, they meet there, and then the resultant force is what we've drawn at R. Now, I spent ages doing this question, and to tackle the problems I was having, I had to draw the whole parallelogram. So that would be my tip for this question, is to draw this whole parallelogram. So now that we've drawn this parallelogram, maybe you can pause the video here and see if that helps you. Also, labeling the angle labeling the angle theta really helps. Okay, so if you're stuck, now's the time to have a look at another hint, and then maybe pause when you've got enough information. Okay, so we know this green angle. This green angle is theta. And since this is a parallelogram, we know that that 30-degree angle has bisected the angle theta. So we know that theta over 2 is 30 degrees, which means that theta itself is 60 degrees. Maybe this is now enough information for you to tackle the problem. So if it is enough information, go have another go and try and tackle this question. If that wasn't enough information, let's continue. So one thing we do is drop down a vertical here. If we drop down a vertical here, we know the height of this vertical is 2 meters because of the question. So if we find this length here, let's label this x and this y, we can find xy by saying tan 60 is equal to 2 over this length xy. So xy is 2 over tan 60, which is 2 root 3 over 3. Okay, maybe that's enough information. Maybe you can pause the video now. If not, let's continue. So the next thing to do is to draw this vertical line, to notice that this angle is 30 degrees by parallel lines. Let's find this distance. So tan of 30, we know, is going to be equal to, well, the height of that triangle I've just drawn is 1, since the BC is 2, over, let's call this length z. So 1 over z is tan 30, so z is 1 over tan 30, which is just root 3. Okay, so we know the length z, we know the length xy, so we can now work out d to x. D to x is going to be getting to the midpoint, so going 1.5 meters across, then doing z, and then subtracting xy. So that's the length d to x. If you do all of that, you get, oops, hold on. If you do all of that, you get 1.5 plus root 3 minus 2/3 of root 3, which is 1.5 plus 1/3 of root 3, which when you do it in your calculator, you get 2.0823 SF. Now this question is pretty difficult, I think you'll agree. It took me quite a while. I think it's quite different to exam questions that you would get, since there's lots of trigonometry involved. It's less of a mechanics question, more of a trigonometry question.